This video is to show you how to do project crashing. I purposely have come up with a project that is very simplistic so that you can focus on project crashing and not get caught up in CPM and PERT in redoing the forward and backward pass. Um, if we were to shorten a project, it should make sense that you can only concentrate on activities that are on the critical path. Because if you were to shorten activities that are not on the critical path, then you don't gain anything. Because remember, the critical path is the path that dictates the length of the project, is the longest path through the project. And therefore, you have to concentrate on those activities that are on the critical path to shorten it. But if you were to shorten one of these activities, then other activities that weren't on the critical path may become critical. So every time, if this was a more complex project other than the one that I'm showing you here, where all of the activities are on the critical path, and that no other additional paths would become critical because I were to shorten. Think back to some of the earlier problems that you've done where there are more paths than just the critical path. If you were to shorten the critical path, then one of those other paths or one of those activities may also become critical. And then you would need to redo your forward and backward paths to determine that and then include that in the analysis. In this case, we're going to just concentrate that we know that all the activities are on the critical path and that if we were to shorten one, no additional paths would become critical. Also, the other thing to think about this is we're doing this at the beginning of the project. If we were already partway through the project, let's say we were on activity C, then you could only crash C and D because activity A and B would have already been completed. But we're assuming that even at the beginning, we're looking at trying to shorten this project. So we want to figure out of all of these four activities, which is the cheapest. And the way to do that is to look at what the normal time is and the normal cost and compare that to how short of a time we can do it in the crash cost. And so we're really looking at the difference. And so the first thing you want to see is how many additional days or weeks can you gain. Let's assume this is given in days. So we're going to look at the difference here. We're going to take the normal time and we're going to subtract the crash time. You could probably just do this in your head, but by doing it in Excel this way, I then can copy down that formula. We'll double check to make sure it copied correctly. It's taking the normal time and minus the crash time. And so what this tells us here is that we could shorten activity A 1 day. So it normally takes us 8 days, but if we were to pay the extra amount, we could get it done in 7 days. And so we could shorten this project by 1 day. Or in regards to activity B, normally it takes us 4 days. We could spend extra and get it shortened to 2 days. And so we can gain 2 extra days. C is probably the biggest one we have here. We can go from 6 days down to 3 days, which is a 3-day difference there. The other thing we need to look at is the cost difference. So once again, we're going to take then the crash cost in this case, because it's the higher amount, and we're going to subtract the normal cost out so we know how much more we have to pay. So this means that if we were to pay for it normally 8 days, it would be $10,000. If we want to shorten it this 1 day, get it down to 7 days, it costs us $11,500 or $1,500 extra. And then we want to copy that one down. So once again, we'll double check here. So on this one, it normally costs $5,000 to have it done in 6 days. But if we're willing to pay $5,000 more, $10,000, then we can have it done in 3 days. Now, the problem is that recognize that these are differing amounts, but they're also differing amounts of time, and we need to make sure that we make a fair comparison. Because for 1,500, we only get 1 day. For 2,000, we actually get 2 days. So we want to figure out what the cost per day or per week or whatever unit of time you're using. So we'll take the cost and we will divide it by the time so that we have that into comparable units. So 1 day is 1,500 for activity A. 1 day is $1,000. Now we can crash it 2 days. So we can crash it 1 day, and if we need another day, we can crash it again. Activity C is $1,667 per day, and activity D is $4,000. So now we have comparison. So now if you were to do this and I were to ask you to shorten this project 1 day, well, because they're all on the critical path, we would go with the cheapest one, and it would be then, I would say, for 1 day, I would crash activity B because it's only $1,000. But let's say I want a second day. Let's say I want 2 day. Well, remember, we can crash this 2 days. We only crashed it 1, but we can go ahead and crash it another day. So we would do activity B again because, once again, it's still the cheapest option. Well, let's say I want 3 days. So another day. Maybe it'd be more appropriate to do this, +1 up. So if I want now 3 days to crash, my next option, I can't go back and crash B again because I've already crashed it the maximum amount I can. So our next cheapest option is to go to activity A, which is 1,500. Activity A, 1,500. I could keep playing this out. Let's say I want another day. So I want 4 days, the project to be 4 days shorter now. Once again, I've used up the 2 days that I had in activity B, the 1 day I have in activity A. The next cheapest is this activity C, and I got 1,667. And I could keep playing this out, recognize that I could crash activity C another 2 days before I would finally get to D, which would be my last option. And so if they ever ask you, for these 4 days, what's the sum total, we would just add these up. So 1,000, 2,000, 3,500, 4,000, 5,167 would be the total for these 4 days. But if they ever ask you what the maximum number of days is, we could crash it. You could keep playing this out, but we could crash it 7 days because we have 7 days there. And then it would just be the sum total of these costs here in regards to that. So that's project crashing. The key to project crashing is, first of all, to make sure that you only want to concentrate on things that are on the critical path. If you had a more complex project and you were to crash something on the critical path, you would have to go back and do a forward and backwards pass to make sure that no additional critical paths became critical, or no additional paths became critical. In this case, there's no additional paths, so we can continue to shorten this project by concentrating on these activities. And then the key is to see how much you can crash it by and what the cost is, and then make sure that you divide that time into the cost so that you have a fair comparison. And then just remember that you may be able to, like in the case of B, yes, it's the cheapest, but remember it can be crashed 2 days. And that's all there is to project crashing.